Hey, Geometry! We are continuing into Chapter 13, into 13.7, where we're doing some more coordinate geometry practice. So we're going to do some with area today, and just kind of review a lot of the content that we've already talked about. So what I'd like you to do is go ahead and see what you can come up with the area of the shaded region in the two documents, or the two items here in number 1. Make sure that you take a look at the coordinates. It'll help you identify your radius and your side lengths and things like that. Press pause and try these problems, please. Recognizing the radius is 4, that helps you get your side length. And again, I don't round my answer here. I don't round my answer until I put the subtraction problem into my calculator to get the appropriate rounded decimal. The second problem, finding the diameter using the Pythagorean theorem or the Pythagorean triple allows you to get the radius to come up with your 30.5. Okay. And in number 2, in the rectangle ABCD, we know A and C. See if you can find BD. Again, when we don't have the segment bar above there, we're looking for the length of BD. This one, making sure you realize that when we are talking about rectangle ABCD, the order in which we name them matters. So it's A, B, C, D. They have to be listed in order. That guarantees that AC is a diagonal and so is BC. Diagonals of rectangles are congruent. So if we find AC, we know it's congruent to BD. Take a look at number 3. Go ahead, pause, and give this one a try as well, please. Move my face. Ideas to recall from this one. Distance formula we can use to find segment BD's length. We can count, or just use subtraction to find segment AB's length and segment BC's length. And then the chord power theorem from our circles unit, chapter 10. Gives us 5 times BE is equal to 6 times 10. We know that this length of BE is equal to 12. And number 4 is the last one I want you to try today. Again, this is bringing back a lot of content from earlier in the school year, earlier in the semester. In this case, we want to know about the length of the altitude from D to EF, so you got to understand what that's going to look like. Use the coordinate grid here, the first quadrant, to help you with this problem. Plotting our points, we should have a triangle that looks like this, and then the altitude from D to EF, making sure we recall altitude means it's perpendicular and it goes through D. We don't necessarily know the intersection point here yet, but we do know that we can calculate the slope of this a different way. I'm going to move more towards area. So if we recall, area is equal to base times height, half of that. 6 times 8 is 48 divided by 2. We get 24 square units for the area of this triangle. But if we rotated this triangle, or if we just called segment FE the base, now the area is 1/2 of segment FE, which we know is a length of 10, times the height, which is the altitude. And that's what the length that we're trying to find. And so I'll just call that A lowercase. But we do know that that's equal to 24 square units. So it's just looking at the area in a different way. When we calculate this, we are going to find that the altitude is equal to 24/5 units. All right, that's it for today. We've got a lot of practice problems in our homework that you guys can try. We're going to do this for over a few extra days as well, just to kind of revisit the concepts that we've been talking about, but apply them all to coordinate geometry now, as opposed to just looking at triangles outside of the coordinate plane. If you have questions, don't hesitate to send me an email, and I look forward to talking to you guys soon.